Hello everyone, welcome to Dave Maths Up. Today I'm going to be talking about linear programming. So if you haven't liked or subscribed, ensure you do so and turn on the notification bell to get notified whenever I drop more videos like this. So that being said, let's get into the activity of today. Now, linear programming is a technique used for the allocation of scarce resources like land, labor, material, time, or money to achieve a desired objective, either to maximize a profit or minimize a cost to a certain constraint. So there are components of linear programming. We have decision variable. This tells us the list of decisions available to the decision maker. We have objective function. This determines the goal of the problem. That is what you intend to maximize or minimize. We have constraints. This sets a restriction to the decision variable. That's maybe restriction in terms of resources of materials or labor. And we have non-negativity restriction. This tells you that your decision variable must not be negative. That is, it must be greater than or equal to 0. Must not be minus this, must be greater than, that is, the least must be 0. That's what I mean. And it also shows us a real world situation that you cannot have a negative amount of money or allocate or use a negative hours or allocate a negative amount of money or produce a negative quantity of product. It is not possible. That's why I mean that your decision variables must be greater than or equal to 0. So now we have graphical solutions to linear programming. This works with only two variables, x and y, and it has the following steps. You convert the inequalities to an equality sign, you identify the visible region, you determine the corner point, then you evaluate each objective function and you choose the point that gives the best optimal value. So we have some various examples that we're going to be looking at in order to solve these problems. Let's see some examples. It says a manufacturer makes 2 types of chairs and tables. 3 machines A, B, and C are required for the manufacture of each product. 1 unit of P requires 2 hours of A, 1 hour on B, and 6 hours on C, while 1 unit of P2 requires 2 hours on A, 5 hours on B, and 2 hours on C. In a given period, there are 24 hours available on machine A, 44 hours available on B, 60 hours available on C. The profit per unit on P1 is 6 naira and on P2 is 9 naira. How many units of each product should be made to maximize profit? So now this question is a maximization profit because we're told to maximize profit. Let me write down all the informations I've been reading. Example 1. It says makes 3 machines A, B, and C. Alright. So let's P1, which is for chair, be represented as X. Let P2, which is for table, be represented as Y. So the information says that there's a profit for P1, which is 6 naira. We will say maximize profit, telling us, since we said 6 naira for chair and chair is represented as X, write 6x plus, and said 9 naira and table is represented as Y, so we have 9y. Then you write subject to. This subject to is trying to tell you that this profit is restricted to whatever we will write next. So this subject to now, it says from the beginning, P1 requires 2 hours on A, and A is under chairs for P1, and it says 2 hours on A, 1 hour on B, and 6 hours on C. So since all of them are under chair and chair is for X, we write 2x, 2 hours on A, 1 hour on B, and 6 hours on C. Then it goes on to say for P2 requires 2 hours on A, 5 hours on B, and 2 hours on C. 2 hours on A, 5 hours on B and 2 hours on C to make P2. Then it said in a given period there are 24 hours available on A. Remember, this is for A, 24 hours. Then it says 44 hours for B, 44, and 60 hours for C. So these are the constraints telling us that we are to achieve this profit. To make P1 we need this, to make P2 we need this, but we need to do all this within 24 hours, within 44 hours, within 60 hours. We should not exceed it. So this is a maximization profit, and you not exceeding a particular thing means you can use up to that thing or less than it. So this equal to now will become less than or equal to, less than or equal to, less than or equal to, because we are trying not to go beyond that boundary. We can use the 24 hours complete or less than it, reason for this. 44 hours complete or less than it, reason for this. 60 hours complete or less than it, reason for this. So looking at it, we have no other thing to do. So this is for machine A, this is for machine B, and this is for machine C. So we can begin. Solution. We're told to how many units of each product should be made to maximize profit. Now, our non-negativity constraint, where x is greater than or equal to 0, y is greater than or equal to 0. Remember, when I explained non-negativity, I said it must be greater than or equal to, because you cannot have a negative decision variable. So we begin. We start this way. From machine A, whereby we have 2x plus 2y equals to 24. When x is equals to 0, y is equals to question mark. Now, note something. In this place, I wrote 2x plus 2y less than or equal to 24. But here, I'm writing 2x plus 2y equals to 24. Remember, when I said graphical solutions to linear programming, the first step was to convert inequality to an equality sign. And that is what I've just done. So, when x is 0, we'll start substituting and computing. We have 2, 0 plus 2y equals to 24. So now we have to find y. We've made x 0. 2 times 0, 0 plus 2y equals to 24. 0 plus 2y gives us 2y equals to 24. To get y, divide both sides by 2. 2, 2, 2, 2. Y is equals to 12. Alright. Now we'll do the same thing. Inverse. When y is equals to 0, x is equals to what? Unknown. So 2x plus 2, 0 equals to 24. 2x plus 2 times 0, 0 equals to 24. 2x equals to 24 over 2 over 2. X is equals to 12. Now, we've known for machine A. We still need to get for machine B, get for machine C. So we repeat the process. From machine B, which states 1x, which is also known as x, plus 5y equals to 44. When x is equals to 0, y is equals to what? Unknown. So 0 plus 5y equals to 44. 5y equals to 44 over 5 over 5. Y is equals to 44 divided by 5 gives us 8.8. Same thing. When y is equals to 0, x is equals to what? Unknown. So we have x plus 5 open bracket 0 equals to 44. X plus 0 equals to 44, telling us x is equals to 44. So that's for machine B. Do the same from machine C, telling us that is 6x plus 2y less than or equal to 60. When in this place now, write equals to. When x is equals to 0, y is equals to unknown. So 60 plus 2y equals 60. 0 plus 2y equals 60. 2y equals 60 over 2 over 2, 2, 2, y equals 30. Do the same thing. When y equals 0, x equals question mark. So we have 6x plus 20 equals 60. 6x plus 0 equals 60. 6x equals 60 over 6 over 6 x equals 10. Now we have known this, we can put it in a diagram. So in order to do that, let's where do we use? So I will clean this side, but let me write out the variables. So we have the coordinates in this place from A, giving us y is equals to 12, x is equals to 12. B, giving us y is equals to 8.8, x is equals to 44. C, giving us y is equals to 30, x is equals to 10. So I can rub this. So for this one, we have y is 30, x is 10. 10 is close to this 9. So to come this way, meet this one, and touch here. Now, like I said from the definition, the first one was to convert inequalities to equalities. That's how we're able to get these things. Second one now is to get the visible region. The visible region is the innermost for maximization, the innermost. So for the how to get the innermost now, first one is get the meeting point between x and y. So the meeting point starting here is this place. Y come from this junction and meet here, x comes from this place and meet here. So this place becomes our A. That is where everything all began. It's just like counting 1 to 3. You begin from 0, then we go to 30, begin from 0, then we go to 45. So this is the first meeting point. Second meeting point, still on this road we've gotten here. Now this y-axis has this meeting point, this meeting point, this meeting point between x and y, but we are calculating the innermost. This one is further away from 0 compared to this, so this one becomes our B because it's the closest meeting point. Now still on this journey, we have another one somewhere here, because if you notice something, this is x-axis, this is y-axis, and this is a connecting line from x, from y I mean, touching x at 12. So this makes another meeting point for our C. Still on this line, there's another meeting point here where this one comes from this place, this one also comes, they now intersect and continue their journey. So this is another meeting point for D. And finally, this is a meeting point, this is a meeting point, but this now is closest to 0 compared to this, just as these two were, and this one becomes our E. That's how we get corner points. So putting this, it will look like this. So you begin with stating the elements, which are what brought about the corner points: A, B, C, D, E. We have A, we have B, we have C, we have D, and we have E. Those are the elements. Now, what numbers do they carry attached to them? Which brings about our X, our Y, and from the question we're stated to maximize profits. In order to get this, A now is at point 0, where everything all began for X and for Y. 0, 0. For B now is at point 8.8. Remember, when Y is 8.8, that is where it began for Y, but it's not on x-axis. This is y-axis. So for it to be on x-axis, which is this lane, it has to come down. And when it comes down, it now meets at 0, because x is coming from this place, has to meet it at this place at 0. For C now, C is not touching y, is not touching x. So we have to trace it to where it touches y, because it's just like this. Looking like this, this is y, this is. So let's say this is somewhere our C. So we have to trace it to where it touches y-axis, and trace it also to where it touches x-axis in order to get our missing variable. So tracing this down, this comes dot 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 to 6, and 6 is x-axis. Alright, now do the same likewise here. Dot 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 dot. So let's just assume this is 8, this is 6, this is 7, this is 8, this is 9. Remember, this is 8.9. This is not exactly 9. 9 is somewhere here from our question. This is 8.9. So let's just assume this is 8, because we are not using a graph to get the exact point. For D, this is the meeting point here. So just as we trace C, we also trace D. Now let me clean this E to put it out, so you'll be able to see how we are tracing the D. So D is at this place. It comes down, 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 down. So should we say this is 9? Because this is 10 here. So let's call it 9 for x-axis, and also trace it this way, which is looking like it's touching 3 for y. Then E from our question says it is 10, because this is the E, this place, it touches at this place 10, and coming towards y, it touches as 0. So now we've known the corner points, we will use it to attain the profits. And how do we attain the profit? Through the question, which says that a profit for P1 is 6 naira and for P2 is 9 naira, which if you remember, we said something like this: 6x plus 9y. So start substituting. So we have 6 open bracket 0 plus 9 open bracket 0 equals to 0 plus 0 equals to 0. Alright, same thing now. 6x plus 9y, we have 6 open bracket 0 plus 9 open bracket 8.8. So we have 0 plus 9 times 8.8. We have 79.2 equals 79.2. So we have 6x plus 9y. We have 6 open bracket 6 plus 9 open bracket 8. We have 6 times 6, 36, plus 9 times 8, 72. We have, this is 8108. Yes, we have 6x plus 9y, 6 open bracket 9 plus 9 open bracket 3, 6 times 9, 54, plus 9 times 3, 27. This is 156781. And lastly, 6x plus 9y, we have 6 open bracket 10 plus 9 open bracket 0, 6 times 10, 60 plus 0 equals 60. Now, remember, when I said graphical solutions to linear programming, I'm showing you the steps which I mentioned earlier. We've converted inequality to equality to get this coordinate. We've identified the feasible region. Now, this is the corner point that I talked about to determine corner point. Next is to evaluate each objective function. How do we do that? Let's see. Evaluate each objective function. Now, the way to evaluate each objective function, now I'll take the remaining two. Say evaluate each objective function and determine the option with the best optimal value. So is to look at this. If the person should go for A, producing x of 0 and y of 0. Remember, this person is producing chairs and tables, which we said chairs to be represented as x and y to be tables to be represented as y, and is to make a profit of 6 naira, 9 naira. So how can he maximize his profit if he's producing tables of 0 and chairs of 0? He's not making any profit. So that is not the best option to choose. Okay, if you're telling you, yeah, produce less of 0 and more of y, is having 79.2 as profit. But that does not seem to be the best option for him to go for. If he should produce 6 of x and 8 of y, he has 108, which seems very fair. If he produces more of x compared to y, that is producing more of chairs, producing more than tables, he has 81, which is less off than this. And if he produces, okay, say you want to put all the investment on x, producing nothing of y, he has just 60, which is poor compared to the rest. So the best option for him to do, if we were to advise the management, we can say the management or the industry, as stated in the question, should produce, since 108 is our best, 6 units of x in this sense. Now, no, it was represented for chairs, so 6 units of chairs, and 8 is for y, which we know as table, and 8 units of tables in order to obtain an optimal value of 108. For the next video, we'll be looking into minimization problem. Bye.